So what we're going to do is we're going to go over higher order partial derivatives. Okay, so just as a reminder about the notation that we've been using. Okay, when we write df dx, that's the derivative of f with respect to x. So as x changes, as x changes, how does f change? Right? And we also write this, to save some notation, as f sub x. And df dy we write as f sub y. Okay, so these measure the change in one particular direction. So far so good. We've seen this notation before. Now we're going to generalize this to the sort of notion of second derivative, third derivative. See how that looks. Okay. So we write the following. To think of this as sort of to think of derivatives as an operator that acts on our function. So here we've got a function. Now we apply this the y derivative operator. Now we apply the x derivative operator. Okay, so we're going to define a new piece of notation, which is to say that this is f sub x sub y. Okay, this is like a second order derivative of our function. And just notice the order in which I write these things down. So there's slightly differing conventions on this. So if you look on, say, Wikipedia, I think they use the reversed convention. I use the convention that the order in which they're written on this side corresponds to the order in which they're written on this side. Okay, so this is a second order derivative, and we can define, similar things. All right, we can take two derivatives in the x direction, say. Another way in which you might see these things written down is to group these d's together. Write that as d squared dx dy xy. And we can group these d's together and these dx's together. Okay, so that's our notation for our second order derivatives.